All right, so in this next presentation, we want to look at 5 ways to improve the performance of your model. In the previous presentations, we've looked at the stages or the steps we use to train, to test, to validate, and to deploy models. In the process of training our models, before we deploy, we need to improve the performance of our models into production, right? So this is what we're going to focus on here. We're going to look at the essential tips for smarter models. Hello guys, if we haven't met yet, my name is Emmanuel Achayo, and I'm a research analyst at a community college in northern Arizona, but I reside in the Valley. So without much further ado, let's look at some of the 5 ways to improve the performance of our model. At the end of the day, the best performing models is what we want because we're trying to solve business problems. Let's look at the first way to improve the performance of our model. And this is probably the most important one, choosing the right algorithm. The algorithm determines how the model learns patterns and makes prediction, directly impacting performance. So match the algorithm to your problem. Different tasks require different approaches. We have classification, regression, clustering, or dimensionality reduction. So when you use AutoML to train your model in GCP, AutoML just makes it easy because it will pick for you the best model type to use for your data and to solve your business problem. But if you use something like Vertex AI, which we are going to, which of course requires a lot of coding or syntax writing, you have to pick the best model, the best model type for training and for prediction or production, whatever that is. So there are 2 types of training. There is supervised learning and unsupervised learning. So let's start with the supervised learning type. So the supervised learning type is what uses things like classification and regression. And then the unsupervised one is the one that uses things like clustering and dimensionality reduction. So supervised learning is when we label our data. Think of giving your model or your computer data of images of cats and dogs, which we already labeled cats and dogs. So the model is learning from an already labeled data of cats and dogs. And that's where we can use classification and things like regression. But then when we talk about unsupervised learning, it's when we don't label this data. So mostly the model is going to use what we call clustering to help us with prediction or inference. So that's the difference between supervised and unsupervised learning. We also have reinforcement learning, which the model learns by retraining and rewarding it for giving us good prediction. Okay? So furthermore, so some of the model types that we can choose here are things like simple linear regression models, logistic regression models, decision trees, random forest, SVNs, KNNs, K-means, gradient boosting, and the rest. For the sake of this video, we're not going to go deep into this. There's so many of these model types you can pick from depending on what you're training. Again, if you're using AutoML, easy for you because you don't need to choose any of this. If you're using Vertex AI, then you have to do more of learning and understanding for you to pick the best model type for you. All right, so that's the first step when you want to really improve the performance of your model. Choose the right algorithm. Let's look at the second thing we can look at or we can improve on so that our performance of our model also gets better. So there are 2 things here. There's quantity and quality. Let's first look at the quantity of data that we feed our model. So we need to use the right amount of training data. Here's a rule of thumb which works all the time. The model performance almost really relies on how much data you give it. The more data you give to your model for training, the better your data is going to perform in production. That is just how it works. So the best performing models are the models that were given a huge amount of data during training. Of course, there's the law of diminishing returns. At some point, the more you give data, the more data you give the model, the worse it performs. But for the most part, for most models, the more data you give it, the better it performs. So the quantity of data directly affects how well a model learns. Okay? Next, we want to match data size to the problem complexity. The more complex the problem, the business problem we're trying to solve, probably the more data we're going to give our model. And then we want to evaluate data needs strategically. Consider model scales, statistical heuristics or assumptions, the data size assessment methods to determine the optimal data set for training. All right, so now we've looked at the quantity. Let's look at the quality of data. Under quality, we want to prioritize high quality training data. Poor or inaccurate data leads to unreliable predictions. So making the model unusable in real world. So that's why you need to have very high quality data. And we talk about quality of data here, we're talking about the variable names. We're talking about the encoding in each variable. We're talking about the data inside those variables, the ranges, the missing values, the outliers. We're looking at all these things. But not just that, even the expertise behind it, like are these particular variables going to really give us what we need? Because you might be having very clean, well-structured data, but those variables or those features aren't going to help us answer our business problem or give us the business solution. Also, things with accessing data quality with proven methods. So we need to assess data quality with proven methods. So we can use two methods, which is called the standard quality assurance method. So under standard quality assurance method is where you look at the foundational things on our data that everybody looks at, like outliers and missing values. All right. Then we go to detailed, in-depth quality assessment, where now we look at even the variables and we even involve experts to understand if those data and those variables are going to help us answer that business solution. So you start with the standard quality assurance and then go to in-depth expert level quality assurance, when we look at the quality of our data that's going to be used for training our model. And then the next step here is to ensure clean data for unbiased results. So, of course, this part of high quality data reduces bias and boosts model performance, enabling trustworthiness and consistency outcomes. Now, there's so much about trustworthiness and openness and transparency when it comes to training models. And this really relies on explainable AI, which, of course, we talked about in our previous video, and just trying to tell the stakeholders, like, hey, this is what the model is doing behind the scenes. Because you're not just going to train a model and then tell people to plug this model on an edge on their using edge on their servers, and then start doing predictions of whatever the model is going to do. We must explain to the stakeholders what the model is doing behind the scenes and why it's giving those results that it's doing. So that brings trustworthiness to our data, and it's part of quality of data we're sending to our model for training. All right, so we've looked at the quality and the quantity of data, which of course affect the performance of our model. Let's look at the supervised or unsupervised learning methods in machine learning. Now, I alluded a little bit earlier on about supervised and unsupervised learning when I mentioned that supervised learning is just labeled data and unsupervised learning is when the model learns from unlabeled data. So understand learning methods that shape performance. So we have supervised and reinforcement learning. Each influence how the model learns patterns and makes predictions. Use the right learning approach to your problem. Supervised learning requires labeled data for prediction tasks, while unsupervised doesn't require labeled data. It must use a clustering to do predictions. Now, when you talk about reinforcement learning, it trains model through trial and reward. So allowing them to learn optimal actions from past experiences. It's just like rewarding a student or a group of students when they do well in a quiz. You tell them, hey, thumbs up, good job, keep doing what you're doing. Here is the next tests for you. Do this test again, they do well, thumbs up. So they learn a pattern that, hey, if we follow this process or if we use this system, we are getting the best results that is required from us. And so let's keep learning that way, or let's keep doing this thing because it is working. If it's working, don't change it, okay? So that's on supervised and unsupervised learning. Now, the last thing that I want to talk about here when it comes to increasing the performance of our model is model validation and testing. So this also is very, very key when it comes to looking at the performance of your model, especially in production. So building a model isn't enough. We don't just build models. We need validation checks on how well it is performing and ensures the predictions are reliable. Next, we need to choose the right validation techniques. Okay, so different models require different validation techniques or methods. Selecting the correct one improves performance and reduces bias. And finally, under model validation, we need to test the model to confirm accuracy. So testing is essential to verify the model's real-world performance and ensure it consistently delivers precise results. Now, I'm sure you guys are following the trend here. We're just trying to make sure that our model performs well, and validation and testing is part of it. We need to validate that our model is working well by giving it some data that it hasn't seen before to see just how well it performs in it. And also testing also. So testing and validating is just, so for validation is just giving it a quiz, and testing is just giving them like a final exam to see, hey, how well are you doing? I've trained you, I've taught you, now I want to give you a test to see how well you're doing. And of course, AutoML and Vertex AI, the entire GCP suite, gives you ways and means to picture or even see some metrics that help you determine the precision or the accuracy of your model and how well it is performing. Okay, and we talked about some of these things in our previous video. That video should be somewhere in this account or in this channel or somewhere. Just look for it, it should be somewhere and watch it. It's a great video. All right, so those are some of the main ways I think that we can improve the performance of our models. So keep trying these ways to improve the performance of your models, and hopefully our models becomes better and better as we train them. At the end of the day, we want to ensure that our clients, our customers, and the problems we're trying to solve are solved the best way possible with the highest amount of trustworthiness and integrity. And this can only be done if we constantly work towards improving the performance of our model by doing the things we've talked about in this presentation. Otherwise, thank you very much for watching. Here's a fun fact I'm leaving you with today. It says, 80% of machine learning work is still data cleaning. Bye guys.